In this section, we'll explore the impact of data design and introduce techniques to improve workbook performance, including data modeling options, connection types, and sources. Goals for this section include introducing data modeling options, including relationships, unions, joins, and blending. Goals for this section include introducing data modeling options such as relationships, unions, joins, and blending, and their impact to workbook performance. We'll compare live versus extract connections and explore optimization techniques for each type. We'll evaluate the performance implications of various data source types, such as flat files, databases, and published sources. And we'll also implement common data design optimization techniques and quantify the performance impact of those. Now that we've talked through the topics and goals for this section, up next we'll be covering Tableau data modeling options. Tableau Desktop provides a number of tools for combining and modeling data source connections, including relationships, unions, joins, and blending. Each option has its benefits related to performance and ability to bring data together. Let's take a quick look at each option. Relationships leverage related fields between tables to create contextually appropriate joins on the fly. This is the default data modeling option inside Tableau and provides a good fit for both optimal performance while reducing the risk of misaggregation, duplication, and incorrect values. Performance-wise, relationships are advantageous because they only activate the part of the model in use at sheet level. This greatly reduces the number of records and complexity of queries needed to answer business questions. Unions append two or more tables to form a new combined table. This type of modeling is useful for tables that have the same columns and data types and can be done in the logical or physical layers. Performance-wise, unions are not overly taxing as they only add rows but not columns in most cases. Since Tableau operates best on tall or row-heavy data, this model tends to work well. Just be careful how much data is brought in, as you'll see performance degradation at some point. Joins merge multiple tables based on join clauses to create new fixed tables. This modeling method is used to add new data columns across a standard row structure and will result in a new fixed table. Improper joins can cause data duplication, aggregation issues, and large tables. Users should ensure that they know the grain and type of data they are combining. For this reason, joins should be used more sparingly than relationships or unions. Often, the extra data and table materialization created by joins will cause performance slowdown. If joins are needed, ensure that your keys between the tables are accurate and that you are limiting the data source filters down to only the data that you'll need. Blending uses separate sources which are visualized in the same view via blended fields. The result is similar to a left join and is best for quick view-level combined data source visualizations. Blends have largely been outgrown by the Tableau platform with the advent of relationships and other modeling options. Since blending processes within Tableau directly, rather than in the data source, performance can be particularly bad for these types of data modeling options. Try and avoid blends unless they are extremely simple and high level. You'll see that our data modeling options range from faster to slower on this spectrum. Note that just because something is faster performance-wise doesn't mean that you should never use a slower modeling type. Sometimes your data scenario will call for a less than ideal modeling structure. In these cases, you'll need to leverage other performance-enhancing techniques to make the model work for your use case and performance expectations of the business. Now that we've talked through a high-level overview of data modeling in Tableau, let's go into our own workbook and apply some data modeling changes of our own. Okay, so we've gone and opened up our Tableau Desktop Performance Start workbook. Note that if you're using Tableau Public right now, this option won't be available because we've got a live connection to our data sources, and Tableau Public does not support live connections. If you're using Tableau Public, you're going to want to start in our other workbook. The workbook for Tableau Public users will be called Tableau Desktop Performance Start Extracted for public users. Note that if you're using public, some of the things we're going to do inside the data source to optimize won't be available to you, but just follow along and make sure that you understand all of the topics that we're covering. Once we get past the extract portion of the course Everything from there on will be one-to-one between Tableau Public and Tableau Desktop for the most part. All right, now that we have our workbook open, we're going to go ahead and take a look at the data model being used in our workbook currently. We'll go ahead and right-click on our data source and just choose Edit Data Source. Note that if your workbook has lost connection to the original files because it doesn't know where they are, you can go ahead and go into your drop-down under Connections, choose Edit Connection, and navigate to the 2 data sources that you'll need to include in this workbook. These should be in the download folder that you've downloaded from the course itself. You can go ahead and click on the Bike Maven data source to get that started and choose Open. Since these are CSVs, they'll automatically be pulled in from the directory that you've opened. Just make sure that it's unzipped. All right, now that we have that taken care of, let's take a quick look at our data model. Now it looks like everything's contained inside the physical layer because our logical layer just has a reference point to our physical layer itself. So we'll go ahead and double click on Bike Maven data, and we can see that we have a join here. Now looking at this join, we're doing a full outer join on zip code between these 2 files. One of them our primary Bike Maven source, and the other our demographic data. We're going to want to change the join so that we can leverage relationships instead. This will be more efficient and only access the data that we need when we need it for the visualization that we're creating. Not to mention the fact that a full outer join is going to produce a lot of nulls and will not be ideal both performance and data-wise for our model. Let's go ahead and X out here, and then we're going to pull off temporarily our demographic data source. So we'll click on the drop-down, choose Remove, and we'll keep just the Bike Maven source in here. We're going to go back to our logical layer by clicking the X, and we're going to bring our demographic data back in. This time we're going to bring it in as a relationship, and these 2 tables won't be combined until we do that inside the actual view that we're creating. We'll go ahead and connect these with those same join clauses that we had before. We'll go with zip code, and in our secondary data source, this is going to be named jurisdiction name. So we'll go down there, choose jurisdiction name, and there we go. So we'll go ahead and close our relationship here, and we've got this set up. For now, we're not going to change the connection type, we'll leave it live. For those of you on public, you've already got this extracted, but hopefully you can go ahead and change your relationship type here and follow along with that. And we'll go back to our start here, and we'll just go ahead and save our workbook. Now we're going to want to save this as a different name so that we don't get confused with what we started with. So we'll go ahead, do File, Save As, and we're going to call this Tableau Desktop Performance Data Design. And we're going to do this for each section of the course. We'll name it based on the section that we're in, and we'll save up until the last lesson in that section. This way you can go back, you can look at exactly what you did up until that section, and review the performance as of that point. This will make it much easier to go back and do performance recordings after each section is complete. Let's go ahead and hit save, and we're good to go. Up next, we'll be talking about live and extract connection types. Tableau Desktop and Server both support live and extract connections. This operation is controlled by the selector on the top right of your data source interface window. Note that you won't see this option in Tableau Public, as only extracts are allowed. Live connections will keep a connection to the source data and will query the database or file whenever a visualization is created, filtered, or otherwise modified in desktop or server. Extracts will pull data from the source and extract it into the Tableau proprietary hyperfile format. Extracts can be scheduled on the Tableau server to keep data fresh while not adversely impacting source platforms with queries. It's likely that your company will need to utilize both live and extract connections for various use cases and scenarios. Extracts are recommended in most scenarios. There are a few good reasons for this. Generally, extracts will improve performance in the large majority of data connections, though extracts may not be available for particular sources like cubes. Extracts can also enable additional functionality like exposing additional features which may be limited with live connections. These can include level of detail calculations and other Tableau-specific pieces of functionality. Extracts allow for offline access to your data, which means you won't have to connect to a network or a database to work on your dashboard. Additionally, extracts support very large datasets, into the billions of records. Extracts are fast to create and with the advent of Hyper, have gotten even faster. Another key benefit is that extracts can be updated incrementally, meaning that they'll only pull the new data in to your data source on a regular basis. A quick note that when creating relationships or joins, each table will need to be the same type, either extract or live connection. An additional note related to connections. When connecting to databases, make sure to use the native connector whenever possible. These connectors are optimized for your particular data source and will yield the best performance for either live or extract connections. For extracts, this won't impact queries against your extract, but will rather make your scheduled extracts more efficient on server. For live connections, this will impact every query going back to your database, so it's definitely something you should think about. Now that we've talked about live and extract connections at a high level, let's go into our workbook and create an extract, because that's going to be the more performant option for us. Alright, so we're back in Tableau Desktop. We're in our Tableau Desktop Performance Data Design. For those of you using public, you can still stay in your extract workbook. We're just going ahead one step and creating an extract. We've already done our data modeling, so all we need to do is go up to our data source, Bike Maven Data, right-click, go down and choose Extract Data. We'll get our extract data window. For now, we're not going to optimize this in any other way, but we'll just go ahead and choose Extract. Alright, our data has extracted, and you can tell that by our double cylinder with the arrow icon right next to our data source. Let's go ahead and save our workbook, and up next we'll be looking deeper into optimizing live connections. Live connections require both database and workbook level tuning to optimize performance. As a developer, you're always in control of the workbook you are creating, and as such, have performance optimization options readily available to you at that level. Let's take a quick look at workbook level tuning options for live connections. One of the best options as the developer to improve performance is to leverage Tableau's relationship models. These models have multiple performance benefits when used with live connections, including query optimization. Calculations like countDistinct are more performant with relationship model because the tables remain separate until activated, unlike normal joins. The second workbook level tuning method is to avoid custom SQL. Custom SQL, while handy for quality assurance and ad hoc testing, is not optimal for Tableau query performance. These queries will format as subqueries for any query driven from the dashboard to the database, resulting in complex queries and poor performance. If custom SQL is required, try leveraging Initial SQL. Unlike custom SQL, which will append the query logic to every query as a subquery, Initial SQL will only happen once when the workbook is opened. This can be used to create a temporary table, which can speed up performance considerably. The only downside here is that Initial SQL isn't available for every connection, and that users will need to reload the dashboard to queue new data outside of the Initial SQL parameters, due to its one-time load upon workbook opening. And the final workbook level tuning option for live connection optimization is to leverage multiple sources. It may seem counterintuitive, but leveraging multiple sources in a dashboard may be the right path. Pulling in multiple sources at different levels of detail will allow you to have smaller sources that can handle queries more easily than one collective source. There are conditions to make this work well, however. You won't want to go overboard and bring in too many data sources into your workbook. You'll also want to limit the amount of cross-data source filtering because that piece of Tableau technology leverages blending. This is one of the methods we mentioned has poor performance and issues of its own. Next, let's take a look at database level tuning for live connections. Beyond the workbook level options to optimize your data connection, you may also have direct or indirect access to tune the database or tables you're connecting to. Your first option revolves around indexing. Indexing tables is one way that you can perform database level tuning to speed up your queries. This process basically creates lookups or shortcuts for queries to be executed on more common dimensions. Look to have your join dimensions and filter dimensions indexed, as those will provide the most beneficial efficiency benefits since they will be used most by dashboard users. Next is data type casting. Though it's very easy to cast fields to different types in Tableau, if the source has many rows and intense calculations, your casting will end up being repeated many times through the entire dataset. If the original fields can't be changed, See if they can be added as new fields of a different cast type for your use. Next, you can also move calculations to the database. Calculations which are at row level, such as level of detail calculations or math calculations, or those who require intensive logic, should be pushed back to the database whenever possible. It can be the case that calculations need to stay in Tableau, but generally speaking, if it's a common calculation that Tableau doesn't need to do, try to move it back to your source. And our final option is to create a new view. Customized views can bring together the data that you're looking for into a single view for your workbook. This view will take the place of your modeling structure or custom SQL queries. While views can take some time and resources to develop, if they are helping many users improve their experience, it can be a worthy endeavor if you have the time to build it. Now that we've reviewed ways to improve a live connection, up next we'll be diving deeper into extract connection optimization. Extract connections can be optimized by configuring extract settings or applying query optimization options like parallel queries or query fusion. Extracting itself will likely produce performance benefits for your workbook, even if you do nothing else besides just extract the data. We can go further in an effort to produce even better performance by configuring extracts to optimize queries and reduce data loads on your dashboard. First, let's take a quick look at parallel query logic and query fusion. Parallel query logic was added to Tableau in version 9, and it allows Tableau to run multiple queries at once depending on your data source. This is not the case for some live connections, such as local flat files. Those sources will need to run queries serially or one at a time. By extracting, your workbook will run up to 16 queries at a time, which will greatly improve speed and processing time. Query fusion is another optimization feature by which Tableau will remove and combine queries in a further effort to run things more efficiently. You can try and promote query fusion by having similar dimensions in your sheets if it makes sense. This will help Tableau create query fusion between different sheets. Now that we've looked at parallel queries and query fusion, we'll look at ways to further optimize your extracts beyond their initial benefits. Reducing extract size is one of the best methods to improve performance. This can be accomplished in multiple ways, including removing unnecessary columns by hiding them, aggregating your data source on visible dimensions, using data source filters to reduce the number of rows in the dataset, and choosing between the logical and physical extracts. Logical is the default, but if you use row-level security or have joins that create large combined tables in the physical view, try physical extracts. Additionally, you should also look at embedding extracts. Embedded extracts will perform best for two reasons. Number one, these extracts will optimize your workbook and will create temporary tables to speed up queries. Number two, embedded sources have quicker data transfer times that don't need to pass across the server to a published source and then into your workbook. Just be aware that embedding too many extracts on your server can cause server headaches later on. You won't want to have too many extracts running that can't be shared between workbooks. So you'll have to balance between embedded and published sources. You should also look at materializing calculations. Materializing calculations will pre-calculate any calculations created by the developer into the extract itself. This will need to be done whenever new calculations are created to materialize them effectively. And finally, leveraging incremental extracts can have benefits. Incremental extracts won't improve dashboard performance directly, but it will lighten the load for the Tableau server, which can help the broader workbook and source itself. Now that we've had a look at extract connection optimization, let's go into our own workbook and apply some of these topics. Alright, we're back in Tableau Desktop and we're looking at the Tableau Desktop Performance Data Design Workbook. We're going to go ahead and right-click on our data source and we'll choose Edit Data Source. Alright, so we're in our data source interface. We're going to click on Demographic Statistics table. Then we'll go over past our %male, click on our Count Gender Unknown. We'll scroll over to the right-hand side, hold down our Shift button, so we highlight all of our extra fields that we won't need. We'll right-click and we'll choose Hide. Now we've got just the fields that we need in the data source. Alright, so we're going to add a data source filter. Let's go up and hit Add, and then we're going to add a filter to Vehicle Type Code 1. So we'll go down to Vehicle Type Code 1, we'll choose Edit, And then we're going to go ahead and exclude all null values. So we'll hit none, so none of these are selected. We'll choose just null, and then we'll choose exclude. And we're going to select unknown. We'll go ahead and click OK. Then we'll click OK one more time, and then we'll go back to start here. Now, this should re-extract our data, but we're going to go ahead and make one more change. So let's click start here, and we're back in our main view. Now we won't need to materialize our calculations again because we haven't added any calculations since we extracted last time, but when we add some more, we should go ahead and do that. For now, we're going to right-click on our data source, going to go down to extract data, and then we're going to go ahead and aggregate on our visible dimensions. Note that we hid a bunch of dimensions before, so we're going to aggregate up to just those that we left visible. We're not going to roll up to any particular dimension, we're just going to aggregate to the dimensions that are left in our view. We'll choose extract, and we'll note that we get a warning here saying that, hey, some of these calculations may change based on what we're doing. That's okay. We're going to click OK there, and we'll just double check our calculations later on and make sure that those are working effectively. Alright, so we've gone ahead and hid a few values, added some data source filters, aggregated on visible dimensions, and re-extracted our data. That should be good for this lesson in the course, so we'll go ahead and save our workbook. And now that we've talked through optimizing our extract, we're going to go ahead and talk through data source types and their effectiveness and efficiency. Choosing optimal combinations of data sources and connection types can significantly impact workbook speed and performance. Flat files such as Excel, CSV, and PDFs are one of the most common data sources for Tableau. Flat files can either be accessed via live connection or through a Tableau hyper extract. First, let's look at live flat file connections. While live connections to flat files provide a closer to real-time data feed, the performance on such connections is typically poor to fair at best with a live connection. Live connections to flat files have to communicate with local share locations for each query from the dashboard. Now let's look at extract flat file connections. Extracted connections to flat files will perform very well due to the data being incorporated into Tableau's hyperformat and disconnected from the local share location of the file for query purposes. For most scenarios with flat files, extracts are desirable. It is rare that flat file data is updated so often that it would require a live connection for a dashboard. Next, let's look at server connections. Server connections include traditional databases like MySQL, SQL Server, Snowflake, in addition to web data connectors and others. Standard connectors that are named are optimized for particular databases and will perform better than generic ODBC and JDBC connectors. Servers typically either have a live or extract option, though some connections require extracts in order to connect. First, let's look at live server connections. For server connectors which allow live connections, these will allow real-time querying of underlying databases from the dashboard. While advantageous in terms of data freshness, performance can suffer in a live connection format to databases. The main reason for this is that most databases are not configured or maintained to be performant with a BI tool like Tableau. There are methods to make live connections more performant from the Tableau end, which we'll discuss later on, but a large burden will fall on the database, hardware, and architecture supporting it in terms of ability to execute queries rapidly. Now let's look at extract server connections. Extracted server connections will perform well in most scenarios, as long as the data is reasonably sized and well structured. The burden of queries is lifted off of the database and placed into the hyper extracts, which should increase performance significantly. While data will not be real-time, most dashboards and analytic tools will meet customer expectations within the extract model. Reminder that extracts can be scheduled to update up to every 15 minutes. Now let's take a look at published sources. Published sources can be either flat files or server data connections, and maintain either a live or extract configuration. The main use case for a published source is that it can be shared by multiple workbooks and dashboards. If a source is embedded in a workbook rather than published separately, it will only be accessible by that particular workbook. This is where the real advantage of published sources comes in. They are ideal for helping manage the validity and security of data and help mitigate too many extracts and connections from being propagated on the Tableau server. Live and extract published connections will operate similarly to their embedded cousins. However, there is one major difference in terms of performance. Published connections require more data transfer time between the data, either server or extract, and the workbook or dashboard. Because the data needs to travel and communicate from farther away, performance will negatively be impacted. You can expect anywhere between 2 and 10 seconds of extra load time for sources which are maintained as published data sources, rather than embedded sources. Deciding between published and embedded sources is a difficult and important decision point for the developer, business, and community as a whole. Too many published sources will impact individual workbook performance, but too many embedded sources will create extract scheduling strain and data source proliferation. Be careful with your data source management and carefully balance the pros and cons of each method. Now that we've gone and talked about our data sources, let's go ahead and run another performance recording on our workbook. If you're following along on your own computer, please close all workbooks locally to clear your cache. This is important because even in desktop, Tableau will cache certain views that you've rendered, and it will make it look more performant than it really is. We want to get a fresh look at our workbook without leveraging a cache. Once you've done that, open your workbook up on a blank page, and we'll run another performance recording. Alright, we're back in Tableau Desktop. We've cleared our cache by closing all of our workbooks and reopening, and we're going to go ahead and run another performance recording. Let's go up to our Help menu. We'll go down to Settings and Performance, and we'll start our performance recording. Then we'll go ahead, move over to our dashboard, and click on it so that it renders. Alright, once it renders, we'll go up to our Help menu, go down to Settings and Performance, and choose Stop Performance Recording. Okay, we've got our new performance recording open. Then we'll go ahead and we'll choose File, Save As. Then we'll go ahead and we're going to name our performance recording workbook, and we'll call this Tableau Desktop Performance, Performance Tests, Data Design. This is just so that we can locate our performance test for data design, but it's a slightly different name than our data design regular workbook. We'll choose Save there, and we'll go ahead and we'll duplicate our events sorted sheet. So we'll go into our events sheet, we'll right click, duplicate, take our start index off of our view, and we can see that executing query is our highest here. We've also got rendering and compiling here as well, in addition to computing layout. This is all just so that we can get a general idea of where our largest queries are, which categories they're in. So we'll go ahead and hit save, and in the next lesson, we'll analyze our results. Now, we only went through one performance recording here, and that's really what we're going to be doing for the rest of the course, but you should be running multiple of these for each section because you're going to get a range of values. You want to get a general idea of how each workbook is performing at the end of each section, and some will be worse or better than others. So you want to make sure you do a handful of these each time so that you can get a true perspective of what performance might be. All right, up next, we'll be doing a performance review for the data design section of the course. Now let's do a quick performance impact analysis for the data design section of the course. Our initial testing showed a range of about 30 to 34 seconds for a render of our initial page. Now that we've done our first pass of optimization while looking at data design, let's review the results of another performance test on our workbook. In workbook performance testing, runtimes for this section ran between 24 and 48 seconds. That yields an improvement of roughly 15 to 20%. This result suggests that most of our problems are less associated with the data source and data model, and more with the other sections that we'll be optimizing, including filtering, calculations, and visuals. However, this is a good improvement for a first cut. Some of the data design improvements that we initialized were updating join connections to use relationships, extracted into a hyperfile format, hid unused columns, applied extract filters to exclude records, and aggregated for visible dimensions. When looking at our event type ranking in their raw aggregated form, we can see that executing and compiling queries are our biggest areas for improvement, along with rendering. Note that most of the green bars will not be additive in nature, as query fusion and parallel queries allow these to run at the same time. So even though they appear to be many and large, a lot of those are going to be running together or combining. Up next is our filtering optimization section of the course.